Before starting with the examples for drawing the stick diagrams in CMOS design style, actually there are NMOS design style stick diagrams too, which is not important, which is not meant in your syllabus in exam point of view. So the only difference will be that if it is asked in terms of NMOS design style, your both pull up as well as the pull down type of devices will be in terms of NMOS logic itself, wherein PMOS logic will be replaced by NMOS type of depletion mode transistors, whereas pull down will be again NMOS logic itself in terms of enhancement mode transistors. Only one pull up device will be having in case of NMOS design style, which you need not worry much about it for the time being. So let us mainly concentrate on CMOS design style. So in your exam, for sure you will be getting this particular question. So draw, they will be giving you certain equations. It may be a simplex equation in terms of basic or universal gates, or it may be a complex expression in terms of dot as well as plus symbols, wherein you are supposed to draw its circuit diagram, stick diagram, and further we will be dealing with the concept of layout diagram. So it will be a combination of three distinct type of diagram asked in one question, or a split type of diagrams asked in terms of only a stick diagram or a layout diagram. Make sure that you are going to remember all these 7 rules before drawing any type of diagrams. Either it may be in terms of stick diagram or layout diagram or circuit diagram. Must and should you have to go through these 7 rules. So you can just go through the rules, wherein first and foremost thing is you have to look into the expression which they have given. In general, they may ask you to draw the stick diagram of an inverter, 2 input NAND gate, 2 input NOR gate, XOR gate, like that, wherein you are supposed to write the equation which you have already known in your digital electronics subject. Sometimes they will be asking you the expression in complex format, maybe in terms of 3, 4 or maximum 5 number of inputs. Till now, I have seen in the question paper they have asked maximum up to 5 number of inputs. So you cannot predict what type of question will be asked. As much as possible, try to solve for different types of expressions. When the expression is given, first and foremost thing what you have to do is you have to check into the expression whether the expression is in the form of whole complement or not. Whole complement means if the expression is in the form of a plus b the whole complement, a dot b the whole complement, ab plus cd the whole complement. So if you are having an expression of such kind, all the procedure what you are going to follow, it will remain same till the 7th step. If you are not having the expression in terms of whole complement form, for example, say they have asked you to draw the stick diagram of a 2 input OR gate or 2 input AND gate. So for 2 input OR gate means the expression will be in terms of a plus b. For 2 input AND gate means the expression will be in terms of a dot b, wherein you cannot find the whole complement form. If you find the expression of such conditions, you have to draw the same thing what you are going to draw it with complement, that is in these examples what you are going to draw. In addition to that, you have to cascade the final output with the help of one more CMOS inverter. For the given expression, try to draw the CMOS logic. Whatever the output you are going to obtain, for that you need to cascade one more CMOS inverter. So how many number of transistors you are going to deal with all these kind of whole complement type of expression. In addition to that, 2 additional or 2 more transistors you will be getting for the expressions which are not in the form of whole complement. So 2 transistors in addition. Why? Because a CMOS inverter is having one PMOS transistor in the pull up part and one NMOS transistor in the pull down part. So in total you will be having 2 transistors in additional to the given expression without whole complement form. So first we will be checking out whether the expression is in the terms of whole complement or not. If the expression in terms of whole complement, then you can follow the further steps. Once you find that the expression is in the whole complement form, second thing is check whether the expression is having a dot sign or a plus sign. If you find that the expression is having a dot sign, This is the thumb rule. If you remember only these two concepts, you can draw the circuit diagram for n number of circuits without any knowledge of its operation. For example, if you find the expression is having a dot sign, make sure that how many number of transistors are there, that is in terms of the inputs given, those many number of transistor needs to be connected in parallel. Dot means PMOS in parallel, NMOS in series. Plus means the exact reverse of this. PMOS should be in series, NMOS should be in parallel. Hope you remember this concept, which we have already seen in case of your first module. Once you analyze the expression whether it is in dot sign or plus sign, next thing what we need to do is we have to count the number of transistors required. Before designing any of the circuit, we have to know how many number of components are needed. So we have to determine what are the total number of transistors required. So this is the simplest equation I have found, which you can remember throughout your semester. The total number of transistors required, especially when you are asked to design in CMOS design style, is twice the number of inputs. N stands for number of inputs over here. Suppose you consider this particular example, y is equal to a plus b the whole complement. So here the total number of input is 2, that is a and b. So n value will be 2. So the total number of transistors required will be 2 cross 2, that is 4 transistors in total. I know how many transistors are needed in total. I have to split them in terms of PMOS as well as NMOS. So it will be the same number of transistors. How many number of PMOS transistors I need? That many number of NMOS transistor has to be required in case of CMOS logic. Both your PMOS as well as NMOS number of transistors will be same. So you can just divide this 2n divided by 2. So how many number of inputs? 2 number of inputs, 2 PMOS transistors, 2 NMOS transistors. Total is 2 plus 2, that is 4. So it is going to satisfy this particular rule. So when we solve one or two examples, we will come to know how to deal with the number of transistor requirement. This is the ground rule which you have to remember. I have shown in simple this particular diagram. Assume that this is your stick diagram. This is not the exact stick diagram, but assume that this block represents your entire structure or the logic which they have given. Say this may be a 2 input NOR gate, A plus B the whole complement. Always reserve this PMOS logic for P type of devices, which we call it as pull up part or top portion. Pull down, that is, it is reserved for NMOS type of transistor. Either it may be in terms of a schematic, that is circuit diagram, stick diagram or layout diagram. This ground rule remains same. Next thing is, try to draw the vertical representation of the circuit. I will let you know what is the difference between a vertical representation as well as horizontal representation of a circuit. So usually I suggest students to refer the horizontal diagram, that is horizontal circuit diagram, in order to make your stick diagram as well as layout diagram easier. So we will see what are these representations in the later slides, and all these things, that is step 1 to step 6, holds good for any type of logics asked in terms of expression, whether it is a simplex expression or a complex expression. These are the rules which we are going to remember throughout for any type of expression asked. Only thing is, if the expression is not given in the whole complement form, you are supposed to take 2 more transistors in addition. Now, what if I am having a expression asked in terms of more than 2 inputs? Here you can see the 2 expressions which I have taken it as an example represents only 2 inputs. It is not mandatory like always all the circuits or the logics should be reserved for only 2 inputs. It can be any number of inputs. If I asked you a plus b plus c the whole complement or a dot b dot c the whole complement, the number of input has exceeded 2. Whenever you find that the number of inputs are exceeding 2 in number, then you are going to follow Euler's path or Euler's diagram. What is this Euler's path? After the completion of two types of inputs, we will discuss in depth with this particular concept. So we should be ready for any sort of questions asked in exam. We are not sure whether they are going to ask you the simplex or the complex circuit. Even for the complex circuit, complex in the sense I am talking about the circuit which is having more than two number of inputs. What has to be done in that case? That we will be discussing it after the completion of the basic part or basic stick diagrams in terms of simplex circuits.